Ever gotten stuck when you're trying to charge your phone in like a foreign country? You've got the right device, but the wrong plug.
Yeah,
It's so frustrating.
totally.
In the world of software, we actually have a very similar problem. We need to get different pieces of code to plug in and work together, ideally seamlessly. And that's where the adapter design pattern comes in.
Yeah, it's like a universal travel adapter, but for your code.
Exactly. So today we're doing a deep dive into the adapter design pattern. We're going to take a look at this presentation, written in Spanish, about the adapter pattern, and then we'll also take a look at some C++ code that demonstrates this in action.
What I think is really cool about design patterns like the adapter is that they provide us with elegant solutions to these common programming challenges that we see again and again in software development.
Okay, so how exactly does this pattern work? I'm kind of picturing a tangled mess of wires in my head. Help me out here.
Okay, so imagine, you're trying to connect a new speaker system to like your vintage record player.
Yeah.
The record player uses like those old bulky cables, but your new speaker only has that like modern input jack.
Right.
What do you do?
Grab an adapter, something to bridge the gap.
Exactly. And that's precisely what this adapter pattern does in code. It's going to sit between two incompatible interfaces, acting as like a translator. In our C++ code example, which we'll look at later, we've got a circle class and we have a square class.
Okay.
And they weren't originally designed to work with this common, what's called a drawable interface.
So it's like the circle and the square, they have their own way of speaking, but the drawable interface only understands a specific language.
Precisely.
Oh, okay.
And forcing them to work together without an adapter would be messy and inefficient, like trying to jam that old cable into the modern jack. The adapter provides a much cleaner solution.
Okay, this is starting to make a little more sense now, but I'm wondering, why is this such a big deal in software development? Is it really that common to have parts of a program that don't speak the same language?
It's actually more common than you might think, especially as software projects grow larger or more complex. You might be working with what we call legacy code, which is kind of like your vintage record player. It still works, but it might use some outdated methods.
Right.
Or you could be trying to integrate third-party libraries, which is kind of like bringing in a whole new sound system with its own, way of doing things.
So instead of like rewriting everything from scratch or trying to force these incompatible parts to work together, we use an adapter to bridge the gap.
Exactly.
That sounds a lot less frustrating than my travel adapter struggles, I have to say. But I'm also wondering, like, why even go through all this trouble? Why not just, I don't know, is there an easier way?
Well, the beauty of the adapter pattern is that it really promotes cleaner and more maintainable code.
Mm-hmm.
Think of it this way. If you just keep trying to force these incompatible parts together without an adapter, your code base will become like that tangled mess of wires, right? Really difficult to understand, difficult to modify, and difficult to fix. An adapter helps you avoid all of that chaos.
So it's not even just about making things work, it's about making them work well.
Exactly. And that's like a key principle of good software design. Now, the Spanish presentation that we have actually highlights 3 common scenarios where this adapter pattern really shines.
Oh, I'd love to hear them. I'm all about finding those elegant solutions.
Okay, great. So the first scenario is all about integrating that legacy code we were talking about. You've got this perfectly functional code, but the interface is outdated. It's like your vintage record player with those old cables.
Right.
Instead of ripping the whole thing apart, the adapter pattern lets you create a bridge to your new system.
So it's like we're finding a way to connect those old cables to your new speakers without having to rewire the entire thing.
Exactly.
Okay, what's the second?
The second one focuses on reusing existing code. So say you have a class that does exactly what you need, but the interface doesn't quite fit into your current project. So instead of copying and pasting code,
Which can be bad.
yeah, it can lead to errors, inconsistencies, all that bad stuff. You can use the adapter pattern to make that existing code seamlessly integrate into your project.
Okay, so it's about working smarter, not harder.
Exactly.
What's that third scenario where this pattern comes in handy?
The third one involves connecting those incompatible libraries and components we discussed earlier. Think of it like trying to connect components from different manufacturers.
Okay.
They might have their own standards, their own protocols.
Right.
The adapter pattern acts as that intermediary, smoothing out all those differences.
Okay. So whether it's legacy code, reusable components, or external libraries, this adapter pattern is helping us create a more harmonious and efficient code base.
Precisely. It's about embracing change and integrating these new elements without having to rewrite everything from scratch.
It's interesting how this pattern reflects a broader principle of adaptation that we see everywhere. We're talking
Yeah.
about travel adapters earlier.
Right.
But like even think about those AC/DC power
Yeah.
adapters, the ones that power our laptops, our phones.
Yeah, that's a great example. Those adapters take that standard AC power from the wall outlet
Mm,
and they convert it to that lower DC voltage that our devices actually need.
right.
It's essentially the same principle as the adapter pattern in code,
Hmm.
taking one form of input and transforming it into something that a different component can use.
Yeah. It's like that aha moment when you realize a concept from one domain applies perfectly to another, and suddenly you're seeing adapters everywhere.
Exactly.
Yeah.
And that's the power of recognizing these patterns. They give us this framework for solving problems in a wide range of contexts.
Speaking of seeing patterns, let's dive into that C++ code example. I'm ready to see this adapter pattern in action.
All right, let's take a look.
Sure.
Remember our circle and square classes that need to work with the drawable interface.
Yes.
So in this code, we create two specific adapters, a circle adapter and a square adapter.
So each shape gets its own personal translator.
Exactly. Each adapter takes an instance of its respective shape as like a parameter.
Okay.
That's how it knows which shape it's translating for.
Right.
Then they each implement a special function called debugger, which is the standard way to draw something using that drawable interface.
So the adapter is essentially saying, hey, I can speak drawable, and I know how to tell this circle or square what to do. It's like each adapter has a little dictionary for its corresponding shape.
Exactly. And the
Okay.
best part is that the main program, the part that wants to draw these shapes, it doesn't need to know the specifics of how each shape is drawn.
Oh, interesting.
It just calls that debugger function on the adapter, and the adapter takes care of the rest.
Wow, that is elegant. So we've got these adapters acting as intermediaries, allowing our circle and square classes to seamlessly work with the drawable interface.
Exactly. And if you look at the main function in the C++ code, you'll see how we create instances of our shapes and their corresponding adapters. We then call the debugger function on each adapter, and they in turn instruct the circle and square objects to draw themselves correctly.
It's amazing how a seemingly simple pattern like this can solve such a potentially complicated problem. It's like having a universal translator for our code.
And the really cool part is that this isn't just a C++ thing. The adapter pattern is incredibly versatile. It can be implemented in various programming languages.
So this is bigger than just one language or one specific problem. The adapter pattern is a fundamental tool in a developer's toolkit, ready to bridge those inevitable gaps in the world of code.
You got it. Recognizing and applying these design patterns is what elevates code from simply working to being elegant, efficient, and maintainable. But the applications go even beyond the digital world.
Wait, you're saying there are even more parallels to be drawn here? Tell me more. So we've gone from trying to charge our phones in foreign countries to vintage record players to even the wiring inside of our devices. Who knew that the adapter pattern had so many parallels in the real world?
Well, it really speaks to just the elegance of the pattern itself.
Yeah.
It's such a fundamental concept.
Yeah.
Bridging the gap between two incompatible things. You see it everywhere.
That actually reminds me, there's that thought-provoking question from the Spanish presentation
Yeah.
that asks, where else in the real world do we use adapters to bridge incompatibilities? It's like a challenge to look beyond the code, right? And to try to find these patterns kind of playing out around us.
And, those observations can actually lead to some truly innovative solutions, even back in our code. It's all about cultivating this awareness of the patterns, right?
Yeah.
And then applying them creatively.
It is funny how something as seemingly technical as a software design pattern can lead to these like broader reflections. It's like the adapter pattern itself is adapting. It's like expanding our understanding of problem solving beyond just the digital.
Absolutely. I mean,
Yeah.
recognizing these connections, these patterns, that's what leads to a deeper understanding, and not just of software, but of the world around us.
This has been really eye-opening. So for our listeners out there who are thinking, okay, I want to become a better programmer, I want to be a more insightful thinker, where should they start?
Just start by paying attention.
Okay.
Notice the adapters in your life,
Mm-hmm.
the tools, the methods, even just like the ideas that bridge those gaps and bring things together. Once you start seeing this pattern, you will be amazed at how often it pops up. And then think about how it can inspire your own creative problem solving.
Yeah.
And it doesn't matter if you're writing code, if you're designing a product, or even if you're just navigating a complex conversation.
Yeah.
You know,
Such great advice. And on that note, we're going to wrap up this deep dive into the adapter design pattern. We hope you enjoyed exploring this really versatile and surprisingly far-reaching concept with us. Until next time, keep those minds curious, keep spotting those adapters, and keep coding creatively.